So in this video, we're going to take a look at some final circle theorems. These ones are involving tangents or are outside of the circle in some way. So let's start off with this theorem here. The angle between a tangent and a chord equals an angent on the circumference subtended to the same chord. So take a look at this diagram. We have our tangent. There it is, highlighted in red. And then think about two lines coming out there, look, right? Okay, so as it says, if we have this angle here between that first line and the chord through the circle, it's always going to be the same if we connect those lines, look, like that. Those two angles are going to always be the same. Okay. So let's take a quick look at some example questions. So in this first example here, look, okay, we've got the tangent, we've got the two lines. So that angle, that 40 degrees is going to be the same thing, look, as A. So A is 40 degrees. Let's take a look at a more complex scenario. So you've got your tangent, look, along the bottom. We've got the two lines coming out there. So that means that this angle that touches that tangent is going to be the same as angle C. That's that same theorem. It's kind of disguised a bit there. So C is going to be 35 degrees. Now, how are we going to find B? Well, we have a tangent that is touching a circle. And if you remember, it's going through the center, and there's one of those nice rules from the last video that says a radius to a tangent is at 90 degrees. Now, if we know that's 90 degrees, and we also know that C is 35 degrees, well, we can do 180 take away 90 take away 35, and that's going to leave us with that angle B, because it's a triangle, they add up to 180. So B is going to be equal to 55 degrees. Okay, so that's the first theorem we're going to take a look at. Now, the next ones, let's take a look at these. Now, we're going to have a look at some chords, some intersecting chords. Now, I'm not proving them in this video, but take a look at this situation in front of us. The rule is this. So if you take the picture, A to X times C to X is the same as B to X times D to X. So what I'm really illustrating here with the colors is if I multiply those red distances together, it's going to be exactly the same as when I multiply these blue distances together. Now, it's a sort of a corollary from that. Okay, we can also have a look at this. If we have a tangent and a chord intersecting at a point there, look, outside the circle, then what I can say is that if I take A to X, which is all the way across there, and I multiply it by the distance between C to X, it's going to be exactly the same value as the distance from P to X squared. Now, let's take a look and see if we can have a go at applying those rules to some different situations. So let's take a look first at this part here, A. So what is that going to tell us? Well, in exactly the same terms as that rule, okay, what we're saying is that A to T squared is going to be the same as T to C multiplied by B to C. Okay, so let's just work that out. Well, we've got A to T, that's going to be 7, so it's 7 squared is equal to 5 multiplied by X. Okay, so what we have here is 49 equals to 5X. So X is going to be 49 divided by 5. Well, that is going to be 9 4/5. So that's the application of the rule there. Let's take a look at this situation here. We've got to find the value of X again. Now, remember that rule. If we multiply the two lines there, look, the 3 and the X together, it's going to be the same as when I multiply these blue lines together, the 2 times 8. So writing that out, we can say that 2 times 4 must be equal to 3 times X. So 8 equals 3X. So if we divide both sides by 3, 8 over 3 is equal to X, which is 2 2/3. Okay, so that's it. Okay, there are more complex questions where these things are disguised a little bit in the questions you're going to see, But in general, that is how we do those sorts of questions.